Right. So let us go for the question paper discussion here. The first question is, which of the following is a balanced chemical equation for this reaction? They had given zinc plus silver nitrate gives zinc nitrate plus silver. So first, let us write the symbol for this element or formula for this compound. Right. So zinc is nothing but Z10 and silver nitrate is nothing but AgNO3. At this you know, right? And then zinc nitrate. So from this we can get the product, right? You can understand that we had already known that zinc is highly reactive than the silver. So silver, we know that we are using for our ornaments. So that is less reactive. That is why we are using the ornaments. Gold and silver we are using as ornaments because of less reactive. So the silver is less reactive than the zinc. So what will happen here? The zinc will go and displace silver and it takes the place of silver. So that is why silver has been written here. Silver has been written here. And here, so zinc has gone to that place means, so instead of Ag, there should be Z10. Right? So Z10 NO3. Z10 NO3. Right? So shall we write this equation like this? Checking out these reactions, you write your own thing. Right? Then you can go for the answer. So Z10, they had given Z10 plus AgNO3 gives, we had made it as Z10NO3 plus Ag. Right. Okay. Now we have to balance these equations. We should have a knowledge that the NO3 is minus and Ag is plus. Right? But the Z10 is 2 plus. So for 2 plus there should be 2 minus. So it should be Z10 NO3 2. So it should be Z10 NO3 twice plus Ag. Right? Then rest of things are okay. Na? One acetone, one acetone, one silver, one silver. NO3 here 2, but here one NO3 here. So in order to balance that, I am making 2 here. So what happened here? 2 Ag has come. Now I am placing the 2 here. Now 2 Ag, 2 Ag, 2 NO3, 2 NO3, 1 acetone, 1 acetone. So just find out this equation. After completing this, you go for this equation. Because if you see these equations before itself, you will get confused. Right? So just work out your own answer and then go for it. So where is this equation? Find it out and tell me. Z10 plus 2 Ag no 3 gives Z10 no 3 twice plus 2 Ag. Right? Oh, this is the right action, right answer. Yeah. So don't look at the answer before getting into idea. You just have an idea, try to frame an equation and then go for it. Next, which of the following will turn phenolphthalein pink? For this, you should have an idea. What is phenolphthalein? Phenolphthalein is an indicator. What type of indicator? It is an acid-base indicator. Acid-base indicator. So acid-base indicator means how it will be in acid and base. In the base, it will be pink in color. In the acid, it will be colorless. Right. Now, which of the following will turn phenolphthalein pink? So, pink phenolphthalein should appear in the pink means what would change phenolphthalein to pink? Base. Which is a base here? NaOH. Yeah. The answer is NaOH aqueous. It has been given. While studying the saponification reaction, what do you mean by saponification? Soap making. Right. What do you observe when you mix equal amount of colorless vegetable oil and 20% aqueous solution of NaOH in a beaker? So you are taking a beaker and you are placing 20% NaOH in that. 20% NaOH and then you are adding some oil, cooking oil into that. So what do you observe when this oil is added to NaOH? What will happen now? Exothermic reaction will happen. Because when this unsaturated fatty acids react with sodium hydroxide, heat will be evolved. That is, when vegetable oil or any oil, vegetable oil, that is an unsaturated oil. Na? This when reacts with the base, the reaction is exothermic. Exothermic means heat will be above. Yes, unsaturated means it is having the double bond, so that the double bond breaks up. At the time energy has been released, that is why. So no, it's not like that. Uh, it depends upon the metal or the thing which we are using. All time, for example, silver will not react, gold will not react. Those things. Actually, for breaking the double bonds, we use hydrogen. That is called a hydrogenation. Hydrogenation. That is, you might have studied hydrogenation. Addition of hydrogen. There is a double bond. We'll add H2 in the presence of a catalyst. Nickel or palladium or platinum. It also a catalyst put. Right. It will fasten the reaction. It will make the rate faster, or else it will take much long time. As I told, in the case of displacement reaction of copper and iron and copper, Fe plus CuSO4, it will take much more time, a day to displace. But in the presence of catalyst, it will not like this. It will displace shortly. Why do we store silver chloride in dark colored bottles? Silver chloride kept in dark. Yeah, we are talking about AgCl. Ag, yes, AgCl will decompose into, yes, Ag, decomposition of silver chloride. That will be the right answer here. Here, to prevent the decomposition of silver chloride. We store silver chloride in dark color bottles to prevent the decomposition of silver chloride to silver into chlorine gas in the presence of sunlight. So, just have an idea about this equation. AgCl gives Ag plus Cl2, right? So this is what I have written. I have not completed, but this is the right equation here. Which of the following gives the correct increasing order of atomic radii of oxygen, fluorine, and nitrogen? I'll tell you. Listen here. This is the order they are arranged in their periodic table, right? This is the order they are arranged in the periodic table. That is the P block elements. So here, this is 10, this is 9, this is 8, this is 7, this is 6, this is 5. Right? This is the atomic numbers. Boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, neon 10. These are the atomic numbers. And one thing we have to understand, let me write here. Across a period, the atomic radius increases or decreases. That's an important question. So across a period, the atomic radius decreases. Across a period, the atomic radius decreases. Why it decreases means, you have to understand, across a period, the shell is same, but the electrons are added to the same shell, right? For example, 5 electrons in boron. For carbon, 6th electron is added to the same shell. And nitrogen, 7th electron is added to the same shell. For oxygen, 8th electron is added to the same shell. For fluorine, 9th electron is added to the same shell. And neon, 10th electron is added to the same shell. When we are going down the period, the electrons are added to the different shells. Right? When we are going across the period, the electrons are added in the same shell. Okay, now, what happens when the electrons are added in the same shell? The nuclear charge increases. Do you know what is the nuclear charge? Inward pull. The nucleus has an attraction towards the electron. So that is called the nuclear charge. Consider that. Let me take a new page and I'll explain you this. So this is a shell. And this is another shell. Right? For example, this first shell, this is second shell. Oxygen has atomic number 8. Oxygen has atomic number 8. Right. So the electronic configuration will be 2, 6. So 2, 6 in the sense here 2 electrons will be, and here 6 electrons will be 1, 2, 3, 4, 5. 6 electrons will be here, and here 2 electrons will be there. Okay. But this is arrangement of electrons in oxygen. But in the case of nitrogen, nitrogen will have 7 electrons. Na? Nitrogen 7. Nitrogen 7, and oxygen 8, and fluorine 9, and neon 10. Right? So already there are 6 electrons here for oxygen. Right? And here for nitrogen, one more electron will be added here. And for oxygen, one more electron will be added here. So already 6, 7, 8. And then neon, one more electron, fluorine, one more electron is added here. For neon, one more electron is added here. First, already 2 electrons are there. But for, what is that? This is for oxygen. La. So, but 2 electrons will be there in the first shell and 6 electrons will be there in the second shell for oxygen. For fluorine, 2 electrons will be there. We'll write like this. Listen here. This is 2, 5. This is 2, 3. 2, 6. This is 2, 7. This is 2, 8. It means that the first shell contains 2 electrons and the second shell contains 5 electrons. It should be written like this. This is first shell. There are 2 electrons here. And the second shell, there are 5 electrons. 1, 2, 3, 4, 5 electrons are. This is for nitrogen. So if you draw the same thing for oxygen means this is 2 electrons are there here and here 1, 2, 3, 4, 5, 6, 7 electrons are there. Oh, for oxygen it is 6 electrons. For let us consider for fluorine. If it is taken as fluorine, it is 7 electrons. The point you have to understand is the electrons are added in the same shell. So what happens? Consider this as a magnet. This is a magnet. Nucleus is a magnet. And the electrons which are revolving around this are iron balls. So always this magnet will have a pull towards inside, towards iron balls. Am I right? So like that, the nucleus in the center will have an inward pull, inward attraction towards the electrons surrounding the nucleus. Right? So when the number of electron increases in the same shell, the nuclear charge increases. Right here. When number of electron added in same shell increases, nuclear charge increases. Nuclear charge increases. So nuclear charge increases in the sense what happens? The size of the atom shrinks, which leads to shrink of size. Which leads to shrink of size. No, that's what I am saying. I am not saying that the size has been reduced. It has been shrinked. Shrinked means in the sense, hold a rubber ball in your hand and press a little. What will happen? The rubber ball will be kutti? No, the size will be slightly reduced. Slightly. Rubber ball புடிச்சு இப்படி அமுக்குறோம் கையில ரப்பர் பால் ஃபுல்லா குட்டி ஆயிருது இல்ல ஆனா கொஞ்சம் குறையுது இல்லையா that kind of shrinkage will be there, right? அப்போ across the period பார்க்கும்போது what happened? So the atomic radius will be like this. Listen here, this is for boron 5 and this is for next 6 and this is for 7 and this is for 8 and this is for 9 and this is for 10. So the difference between the first and last will not be much. Will not be much. But there is a decrease in atomic radii. But there is a decrease in atomic radii. Got it? But there is a decrease in atomic radii. That is what happening here. So, which of the following gives a correct increasing order of atomic radius of oxygen, fluorine, and neon? Now tell me which is having which is a increasing order. Increasing order means yeah, small to higher. Which is having the lowest atomic radius here? Wait, check it out. Which is having the highest atomic number here? No, this is nitrogen. This is not neon. This is oxygen. This is fluorine. This is nitrogen. Yes, 9. So this should be the first. Right? And then second one? Oxygen. 8. And then? That's the thing. So here you find out the right answer. That's the thing. Okay. So they had given the explanation for that. In the modern periodic table, the atomic radius decreases. What I explained, the atomic radius decreases with increasing atomic number from left to right. The atomic number, fluorine, nitrogen, fluorine, oxygen, nitrogen are 9, 8, 7 respectively. So atomic radius will decrease from nitrogen to N to E. Oh, it has been F. They mentioned as E. Nitrogen to fluorine. Right. Next. Identify. This will be interesting. It will be like a puzzle. Let us solve this one. Identify X, Y, Z based on the information given. Right. X is a non-metal. First clue. X is a non-metal, which is an important constant of our food. Uh, it forms two oxides, Y and Z. Y is toxic and causes suffocation sometimes. Y is toxic or discuss suffocation sometimes death. So Y, if you inhale, it is a gas. It is an oxide formed by the X. It suffocates. When you inhale that, it suffocates and sometimes causes even death too. Right? Pen master. This is what I'm writing here. You say edit. Right. The Z is responsible for global warming. This is the highest key you are having here. Highest key. Global warming in the sense. Yes. Global warming means that is due to the greenhouse gases. First, I'll explain what is global warming. That will be interesting to you. Listen here. Global warming in the sense, this is our Earth, right? From our Earth, we are making much more pollutions and we are sending some gases to the atmosphere, right? We are sending some gases to the atmosphere. There, ozone layer is there, right? It consists of O3, that is oxygen, O2 is oxygen, O3 is ozone layer. These gases like CO2, SO2, these kind of gases are come as a pollution. This what happens, this goes and make a hole in the ozone layer. This destroys the ozone. So what happens here, the sun produces the harmful radiations as well as good radiations, UV radiations. So the ozone layer serves as an umbrella for us. So if there is a hole in this umbrella, what will happen? The sun's rays will directly come into the earth and it will fall here. So because of that, what happens? There are freezed points in the polar regions. So frozen ices were there. So if the sun's radiations fall directly on the ice, means what will happen? The ice will melt. If that much of ice, huge amount of ice will melt, means what happens? Flood will be there. So what will happen? The flood will come over to this place and everything will be destroyed. So this is called a global warming. Global warming in the sense we are giving out much more pollution, gases, polluting gases. That polluting gases makes a depletion in ozone layer, make a hole in the ozone layer. Due to that, what happens? The UV rays directly falls on the sun. That is one point. And another point, these gases are called greenhouse gases. Greenhouse gases. Greenhouse gases. Greenhouse gases in the sense these gases will form a cloud-like structure around the earth. Right. This is the earth, and the heat radiated from the earth, these gases will not allow the heats to pass through them. This will revert back the heat to the earth itself. Right? So the heat radiated from the earth will not get into the outer space. These gases will block the heat radiations and send back to the earth. So what happens? The heat radiated from the earth will go to the gas and it comes back to the earth. Then what happens? The temperature of earth increases. The temperature increases. So temperature increases means warming. That is called a global warming. The globe has become warm. Because of this, pollutant gases does not allow the heat radiations to escape into the space. This forms an umbrella-like structure and that reflects back the heat radiation to the earth. That is why the earth get warms up. That we call as a global warming. Right? That we call as a global warming. Right? So Z is responsible for global warming. So now we have to identify. Yes. Yes. No, it's not like it's a gas. They are given. Na? X is a non-metal, right? Non-metal, right? It forms two oxides. So this is a exact key. Global warming means you can easily find out that is CO2. Carbon dioxide is an important greenhouse gas as well as a pollutant. So vehicles are emitting carbon dioxide and another gas is CO, carbon monoxide. So these two are Carbon monoxide causes what is that? Mild headache and something, some bad effects, and at lethal doses, it can lead to coma and even death. I think in one film they had used carbon monoxide to take them to the coma. Sivakarthikeyan film. Yes, இது ஒரு சிவகார்த்திகேயன் படத்துல. So that kind of gas is carbon monoxide gas. So carbon dioxide we know as a well-known pollutant. So what will be X then? Exactly, super. So carbon forms two oxides, carbon monoxide and carbon dioxide. So carbon is an important constituent of our food. So what is our food? Carbohydrate na. What is your food in the morning da? Yeah, carbohydrate, arisi, carbohydrate. So what's the formula? C6H12O6. So carbon is the main component. So that is why they given us carbon is an important constituent of a food from two oxides, CO2 and CO and CO2. Why is toxic and causes complete suffocation? That's why. Why is toxic? That is CO is toxic and causes suffocation and sometimes even death. And Z is responsible for global warming. CO2 is responsible for global warming. Let us check the answer. Yeah, exactly. That's the answer here. So non-metal X is carbon, which is important constituent of food. Carbon forms two oxides, Y is CO and Z is CO2. CO is toxic and causes suffocation and sometimes death, while CO2 is responsible for global warming. Right. Next. The structural formula of X and Y will have the same molecular formula C3H6O. No, C3H6O. 60, there will not be 60 hydrogen in any compound. Right? Oh, C3H6O. Let us try to draw this. It's quite simple and easy, right? Listen here, C3 means I made three carbons, and you know that already the terminal carbon should be, yes, please. The terminal carbon should have the CH3, right? There is only one O, right? So there is a possibility of OH group or CHO group or C double bond O group. That is C double bond O is nothing but ketone, OH is nothing but alcohol, and CHO is nothing but aldehyde. Right. So let us check it out. Let us write first. We'll write CH2OH. Right here, let us write CH2. Just now count the number of hydrogen here. H6 only, na? So CH3 5, 7, 8, 8 has gone. So it is not that. Right. Then we can go for CHOH is ruled out. This has been ruled out. Then if you write CHO instead of these things, let me write here. CH3, CH2, CHO. So now check the number of carbon and oxygen. 3, 6. Am I right? 3, 6. C3H6O. This is right. So 1 is right. Okay. This is right. And let us go for another compound. CH3, C double bond O, CH3. Now count the number of carbon and everything, carbon and hydrogen here. 6, 3 carbon, 1 oxygen. So this is also okay. So they had given only two things, na? So this is enough. So we can find it out. One is this one and another one is this one. That is one is an aldehyde, another one is a ketone. So what is the name of this aldehyde? 1, 2, 3 carbon atoms. Propanol or propanaldehyde. And what is the name of this ketone? Propanone. Very good. Propanone. Right. So where is the option? Check it out. This is propanaldehyde. This is propanone. This is one propanone, two propanone they had given, but any of the thing is right. This is also propanone. This is also propanone. So this is not. And this is also propanone. This is acid. This is not because there is only O. Only one O is there. They had given two. So these two are ruled out because there are two oxygen here. But in the question there is only one oxygen. So these two are ruled out. And here there are two ketones. CO. This is not a ketone, but this is what is that? The number of hydrogen varies. 3, 6, 8 hydrogens are there, but they get only 6 hydrogen. So check out the number of hydrogen. Here 6, but the pair is not matching. This is right answer. C3, CO, C3 right answer, but another pair is not matched here. So this is also ruled out, and the first one is the option. The first one is the right option. Right. Okay. This is the thing. And next, that's it for in this paper, chemistry objective. Okay. 7 questions only they had given. Let us check, is there any objective questions? Is biology? Assertion reasoning. Yeah, this is an interesting question, and this is an often asked question, pa. This we have to understand, right? Before seeing the answer. Listen here. Fresh milk is in which baking soda is there, takes longer time to set as a curd. Baking soda decreases the pH value of the fresh milk below 6. Right. So, wait, exactly, right. I'll explain the content. Actually, usually what the milkman will do after getting the milk from the cow, he want to preserve it for the long time because if he takes the milk at 5 a.m. now, he has to deliver till 6 p.m. So for a long time, for the milk to be, what is that, to be in good condition, what we have to do, the acidic content should be reduced. Acidic content, acidic content should be reduced, should be reduced, or the pH should be below 6. No, the pH should be above 6. The pH should be above 6. It's not below 6, the pH should be above 6. Right? So baking soda is nothing but a base. It's a base. When the base is added, what happened? The acidic content of the milk has been lessened. Then it has more time to set as a curd. First is right. That is, the fresh milk in which the baking soda is added take a long time to set as a curd. Second one, the baking soda decreases the pH value of the fresh milk to below 6. No, this is not right. The baking soda is a base. It increases the pH value. Base means it should be above 7. Got it? So it increases the pH. So this is wrong. So first one is right, second one is wrong. So what is the answer here? Assertion is true, but reason is false. Right? That's the thing. Can you understand?
ஆசிட் வந்து pH வந்து குறைஞ்சா எப்படி சார் வந்து ரொம்ப நேரம்
No. In acid medium, the germs, the enzymes will react faster. That is why we are having acid in our stomach. We are having acid in our stomach. In acidic medium, the enzymes will react faster and they will make the conversions easy. But if it change into basic means, the enzyme should not react that much faster. They will be slowly working. That is why. That is the reason. Okay. So the answer is yes, the same thing. Assertion A is true, but reason R is false. Fresh milk in which baking soda is added more alkaline in nature. Alkaline, that's what I said, base. Alkaline base, both are equal votes. Therefore, the add produce something missing here. Produced to set into curd will be neutralized by baking soda and added by the milkman. Hence, it stays longer time to set aside. After the baking soda, it will become more alkaline nature and the pH should be increased above 7. Right? The pH will be increased above 7. Right? This is biology. This is physics. Okay, we'll stop and we'll continue. Right. Observe this figure. What happens when the tube is heated? We are having copper nitrate here, CuNO3 twice. We are having copper nitrate here, NO3 twice. Write the balanced chemical equation of the reaction. Identify the brown gas evolved. Right. You have to understand, you have to keep one thing in mind. When nitrate salt is heated, nitrogen dioxide will be evolved. NO2 will be evolved. This symbol indicates evolving, right? And this nitrogen dioxide will be brown in color. Will be brown in color. This you will learn in your plus two. So what happens when the copper is heated? Copper nitrate is heated. The copper nitrate is heated. This gas will evolve. Okay. Write the balanced chemical equation. CuNO3 twice, NO2 has got evolved, plus Cu will be there. Yes, copper forms copper oxide. So NO2, it gives NO2. Along with that NO2, it gives oxygen as well as copper oxide. So this is copper nitrate. It gives copper oxide, oxygen and nitrogen dioxide. You have to remember this equation. And this is brown in color. That is why it has been indicated. So and remember, copper oxide is black in color and oxygen is colorless, right? So is it clear? Remember this question. When this question is came, you should not leave this one. So thing is, you have to keep in your mind that along with nitrogen dioxide, copper oxide as well as oxygen will be evolved. That's a point. Copper oxide because of color, we'll remember these things. Copper oxide and oxygen will also be evolved, right? Next question. Yes. Why does carbon become stable after sharing 4 electrons? What type of bond is formed by sharing? What's the answer? Yeah. Yes. Sharing means we can write that it is a covalent bond. No doubt in that sharing. Why carbon becomes stable after sharing 4 electrons? Yeah, listen here. Already it is having 4 electrons with that. And if it is has hydrogen gives one electrons here, right? Let us consider hydrogen here in all the sites. Now the number of electron present around the carbon is 8. So 2, 2, 2, 2. 8 electrons are there. So 8 electrons leads to stability, right? That is why the carbon is stable. Yes. The atomic number of carbon is 6. You have to know how to write the answer, right? Because you are answering good. But the presentation part is most important, right? You should read the answer even though if you know the answer, then you have to know how they had presented the answer. Then only you can do it in your exams. So the atomic number of carbon is 6 and its electronic configuration is 2, 4. This we didn't say, na? We directly gone into the point. But we have to say all these things too. It is tetravalent in nature and it has 4 electrons. It can neither gain nor lose 4 electrons to acquire the nearest noble gas configuration. Listen here. We didn't tell all these things. We didn't tell all these things. Directly we had gone to the answer. But these things are all required for a good answer. Right? And the only way is to share 4 electrons with the electrons of other atoms. The type of bond formed is covalent bond. Is it clear? So these kind of answers should be presented. Then, why covalent compounds are being poor conductors of electricity? Why do covalent compounds will have low melting and boiling points?
Yeah, very strong.
Yes. Poor conductors of electricity. Why do have low melting and boiling points? What you have said is right. The covalent compounds are poor conductors of electricity as they do not have charged particles since the electrons are shared between the atoms. Charged particles are formed. Remember this word. Charged particles are formed when the electrons are transferred. Right? There is no transfer of electrons, so no charged particles. So no electrons, no charged particles. So if there is no charged particles, it is difficult to conduct the electrons, right? And then covalent compounds have low melting and boiling points Because they have weak intermolecular forces. Yes.
லோ மெல்டிங் பாயிண்ட் வந்து சீக்கிரமா உருகிக்குமா லைக்
Yes, yes, yes. Right. They have weak intermolecular forces due to which little energy is required in changing the state by overcoming the force of attraction. Can be easily melt down, can be easily boiled down. Right? Because you have to understand the reason, right? Weak intermolecular forces. This is a keyword here. If you're writing the keyword and you have to understand this one, you have to underline this one, right? So weak intermolecular forces and they do not have charged particles. These are the keywords here. So while you are writing your answer, you have to highlight your keyword always. The force between two molecules. For example, if A and B forms together a bond, there should be attraction between the A and B that are called intermolecular forces. Inter means in between. Molecules means you know that. So the force of attraction between two molecules, that is called intermolecular force. So the keywords here are they do not have charged particles. They do not have charged particles. Point number one, right? And they have weak intermolecular forces. These are the 2 points. Why are the covalent compounds being poor conductor of electricity? They do not have charged particles, so they don't. They behave as a poor conductor of electricity. And why do covalent bonds have low MP and BP, low melting and boiling points? Because they have weak intermolecular forces. So, because of that, little energy is required to change the state. Clear? Biology, physics. Yeah, this is an interesting question. Right. DDT was sprayed in lake to regulate the. Yes? Right. Well, DDT is there. I'll explain this one. DDT was sprayed in lake to regulate the breeding of mosquitoes. How did it affect the trophic levels in the food chain associated with the lake? Justify the answer. So first of all, what is DDT? DDT means para, para dash dichloro diphenyl trichloro ethane. That is a full form of DDT. Para, para dash dichloro diphenyl trichloroethane. Dichloro diphenyl trichloroethane. That's a DDT. So the DDT, it will have a nice structure. You have a look over here. It will be having a good structure. Here, this is Cl and H here. Yes.
HSBG.
Yes, G.
ஜி உங்கள் கேவிபி அக்கௌண்ட் அட்ரஸ் சேஞ்ச் பண்ணோம்ல
Yes.
கண்டென்ட் எழுதி கொடுங்க நம்ம மாற்றிடுவோம்.
Sure, sure, sure.
கண்டென்ட் எழுதினீங்கன்னா நம்ம ஆஃபீஸ்லேயே நான் இன்னைக்கு இருக்கப்போ கூட நான் டைப் பண்ணி வாங்கிடுவோம். நவீன் மாஸ்டர்கிட்ட கொடுத்தா வேறு ஆதார் கார்டு ஜெராக்ஸ் வேணுமாம்மா?
I'll send the Aadhaar card. They can take the copy now. Yeah, we'll do. Within this day, we'll finish. I'll give the content. I'm finishing class just 5 minutes. Yeah, well, yes. So listen here. So this is the structure of DDT. Right? Here this, this is all are Cl. All are Cl. So for you to understand, but you have it in mind, this is the structure of DDT. Right? So coming to the point, the DDT is sprayed in lake to regulate the breeding of mosquitoes. What is the problem in DDT now? That we call it as biomagnification. Do you remember the term biomagnification? What do you mean by biomagnification? Yeah, exactly, super. So what happens that if we spray the DDT, what happens? The DDT was absorbed by these planktons, right? And small fishes eat the planktons. So that is transferred to small fish. And large fish eats the small fish. That transferred to the large fish. And hogs eats the large fish. That transferred to the hog. So this is in your biology, but in chemistry we can say that it is in chlorophyll even, right? They are chlorophyll. They are using as a pesticide. Na? They are spraying in chemicals to control the pest. So in the leaves, the pesticide sprays means it stays there. When goat eats the leaves, it goes to the goat. When man eats the goat, it comes to the human. Likewise, it comes to our body also. That is called biomagnification. Okay, that's the thing. Then have the answer. DDT being a non-bio. This is a point you have to understand. Non-biodegradable pesticide. It cannot be degraded automatically, right? Biologically. So non-biodegradable. It will enter into the food chain from the first tropic, and it goes on to the higher level. Goes on to the higher level, right? Next, section C. Based on the group of valency of elements, write the molecular formula of the following compounds. Give justification for the each. Right? Based on the group valency.
Group balance.
Group valency means we are having the periodic table. Na? S, P, D, and F. We are having the groups like this. Na? Each group has a common valency. For example, first group will have valency 1, second group will have valency 2. Like that, or each group has a common valency. Right. Oxides of first group elements. Yes. Oxides of first group elements and halides of 13th group elements. And compounds formed when element A of group 2 combines with element B of group 17. So A belongs to group 2 and B belongs to group 17. If they combine together to form an oxide, to form a compound, what will be the formula? That's the thing.
B வந்து 2 times MgC 2 example.
Exactly. That's the right answer. Right. So let us get into the answer here. The valency of group 1 element is 1. The valency of oxygen is 2. So metal, it is 1, oxygen is 2. We have to crisscross the valency. Simplest way. So metal, valence, metal, oxygen. So metal has to get number 2. Two metals for one oxygen. So you know that metal is nothing but plus 1. Oxygen is nothing but minus 2. Right? 2 cancel, 2 minus, we need 2 plus. So we need M2O. So now 2 plus 2 minus. So the compound must be neutral, or the charge must be neutral, then only the compound can exist. So here plus 2 minus 2, the charge is done. That is why we have to, the formula is M2O. We can write the formula as M2O. Right. Oxides of first group elements have the formula of M2O. Right. Shall we guess the formula for second group elements if possible? Second group elements. Yes. Second group, the valency of second group is, yeah, the valency will be 2. The oxygen also, the valency is 2. So what happens? So 2, 2. Or else we can cancel 2. It can be written as
MO.
MO.
Mங்கிறது என்ன?
Metal, second group element, whatever it may be. Yeah, metal. O is oxygen. Right. Let us take an example of calcium. This is second group element, right? Let us take an example of oxygen, CaO. So what happens here? The calcium gives 2 electrons and the oxygen accepts 2 electrons. So Ca2 plus O2 minus. So this is CaO. So this is the oxide formula for second group elements. Got it? Right. Then halides of elements of group 13.
Halides.
Halogens. Halogens. Chlorine, fluorine, bromine, iodine. These are called halogens. Group 17 elements are called halogens.
Group 17.
These are called halogens.
அப்போ group 13
No, no, no. Halides of elements of group 13. Group 13, there are group of elements. Na? If they react with group 17, they form the halides. Right? Halogens react with anything to form the halides. We call that halides. Let me give an example like this. Listen here. Sodium is first group element. Chlorine is 17th group element. So this is called as a halide compound.
NaCl.
Ah, Cl is a halogen, so that we call it as a halide, right? So here halides of elements of group 13. Yes, the valency of group 13 elements is 3. The valency of halogen is 1. For example, halogen is 17th group. Na? If it accepts one electron, it will become 18. So valency is that the number of electrons it can accept or donate. So the valency of halogens is 1. Here the group 13 in the sense it has 13 electrons now. If it gives out 3 electrons, 13 minus 3, it will become 10. So the valency is 3. So for metal the valency is 3, for halogen the valency is 1, crisscross the valency is, yeah, exactly, we'll do. Right? So that's the thing. We can give examples of these things. That is the halides of 13th group will be having the formula MX3. Right? Group 13 will be MX3. And compounds which formed an element of group A from group 2 combines with group 17. Right? Group 2 with group 17. Right? Group 2, the valency is 2. Group 7, the valency is 1. Here metal, here halogen. Here we can crisscross the valency. So it will be MH2. Right? Metal hydrogen, metal halogen, MH2. That is what they had given here. Have a look here. Have a look here. The valency of group element is 2, the valency of group 17 is 1. So we are crisscrossing that, we are getting the AB2. That is what I have done as MH2. M for metal, H for halogen. Actually, H should not be there. Actually, halogen should be denoted by X. Should be MX2 only, not H2. H2 means it will mention hydrogen. The right formula is MX2. Right. Okay. That's it. That's all the answer for this group. This carries 3 marks. Okay. These are all biologists. Yes. Yes. State the law of conservation of mass. Oh, it's there. Okay, welcome. As applicable in a chemical reaction, illustrate with an example. So, law of conservation of mass in the sense, what is law of conservation of mass? Yeah, mass can neither be created nor be destroyed. So let us go for this. Mention any three information by a chemical equation. Let us write a chemical equation so that we can understand easily. We can go for yeah, Na2SO4 plus BaCl2, and it will give BaSO4 plus NaCl, right?
Balance the two.
That will balance. So if you check here, the sodium sulfate is in solid state, and barium chloride is in solid state, and barium sulfate it will be in the
Precipitate. White.
precipitate form. It is in the aqueous state, aqueous precipitate, and sodium chloride it is also dissolved in water, right? This is in the solid state but dissolved in water. So thing is, what happens in the reactant side? Both are solids, but in the product side, it has been converted into one aqueous and one solid. Let us have one more equation like this. That is, we can see in one equation. That is CuNO3 twice. It gives CuO2 plus O2, not CuO2, CuO plus O2 plus NO2. Here the O2 and NO2 are gases and CO is a solid. This is a solid and this is a solid and this is a gas and this is a gas. So what happens when the reaction moves on, the solid gets converted into another medium. That is, the state of matter changes. Solid can change into liquid, liquid can change into gas in the reaction. Right. This gives a number of atoms of molecules of reactants and products involved. If you balance this equation, this is what it tells about the number of atoms and molecules involved in the reaction and chemical formula of the reactants and products and catalysts involved in the reaction. So these are the details we are getting from the chemical reactions. Right. Then law of conservation of mass we know, but we have to learn how we can explain through an example. The law of conservation of mass we know that matter can neither be created nor be destroyed in a chemical reaction. This everybody will write, right? No doubt on that. But how we are going to illustrate that, how we are going to explain that. The gist of the above statement is the mass of the products in a chemical reaction should be equal to the mass of the reactant. That is why we are balancing the chemical equations, right? So let us take an example. CaCO3 gives CaO plus CO2. So what is the molecular mass of CaCO3? Calcium it is 40, only one calcium, so 1 into 40. Carbon it is 12, one carbon, 1 into 12. Plus oxygen it is 16, so 3 into 16. So totally if you count, the molecular mass of calcium carbonate is 100 units, right? And molecular mass of calcium is 40, oxygen is 16, so 56. And molecular mass of CO2 or carbon dioxide 12, oxygen is 16. 2 oxygen are there, so 2 into 16, so that is equal to 44. So what is the molecular mass in LHS? CaCO3 100. And what is the molecular mass in RHS? CaO plus CO2. That is 56 plus 44 100. So then only the reaction is valid. For this reaction only, for this reason only we are balancing the equation. Right, I already told you Ramarpalli Muli petrol has been failed because of he has given 10% input and he has taken 100% output. Is it possible? 10% increase 10 gram the reactants are of 10 grams, but the product is of 100 grams. It is not at all possible. That is what law of conservation of mass states it. What we are giving it, that must be equal to the product, either in the form of any form of energy. Right? So we are giving 100 units, 100 mass inside, 100 atomic mass inside, but and there must be 100 atomic mass. Right? So that's the law of conservation of mass. Riddle. We can go for this riddle. This will be interesting. An organic compound next with the molecular formula C. They didn't give the molecular formula. Undergoes oxidation in the presence of alkaline KMnO4 to form a compound Y. So let me write short notes like this. X undergoes oxidation to give Y. Right. X on hitting the presence of corn H2SO4 at 443 Kelvin gives Y. The same X on heating with corn H2SO4 at 443 Kelvin gives Z. Right. Which on reaction, in a reaction kudukala, which on reaction gives back X. Identify X, Y, Z and the reactions involved. Right. So we have to find out. They didn't give the molecular formula. Only hint they had given is this oxidized X on oxidation gives Y. X on dehydration, H2SO4 means you have to understand dehydration. Dehydration gives Z. Z on reverse reaction, addition of water gives back X. Right. Upon dehydration nadakkanumna, it must be an alcohol. Yeah, alcohol la OH group irukku. So that H2O release are easier. And alcohol oxides panna we can get an acid. Yes. Yeah, what you are saying is right. Aldehyde we are having HO, CHO, and in alcohol we are having OH directly, right? What I'm coming to say, this OH can combine with any hydrogen easily and can be relieved as H2 minus H2O easier poidu. That is why alcohol I prefer, right? Okay, and okay, so this must be an alcohol, this must be an acid. But they did not given any restrictions regarding the, what is that, the molecular formula. So for my concern, I can take n number of acid. Na? Okay, let me check. If I take CH3, CH2, if I consider CH3, CH2OH as X, right? So on oxidation, it will give CH3, COOH, CH3, COOH. It will give CH3, COOH, right? On dehydration, minus H2O, it gives CH2 double bond CH2. This is the simplest thing I expect for this. Yeah, this is the thing. That is what they also mentioned. So this is an alcohol and this is an oxidizing agent. Listen here, you have to remember from here itself, this is a strong oxidizing agent. Strong oxidizing, strong oxidizing agent. Both the thing. This is called K2Cr2O7 actually. K2Cr2O7. Potassium dichromate.
KM4 strong
Yeah,
oxidizing.
strong oxidizing agent.
K2 low strong
K to
oxidizing.
this potassium dichromate. Both are strong oxidizing agents. So strong oxidizing agent in the sense you have to remember this too. That is an alcohol when it is oxidized, it gives a carbonyl compound. The carbonyl compound when it is oxidized, it gives corresponding acid.
Okay.
It gives corresponding acid, right? So when the oxidizing agent what we are using is so strong, the alcohol can directly convert it to acids. So that kind of strong oxidizing agents are this one, alkaline cold KM104 and potassium dichromate, right? That is why without getting into the carbonyl compound, without stopping in the intermediate stage, the alcohol directly converts into the acid. So the if you use a mild oxidizing agent like CrO3, first the alcohol will convert into a carbonyl compound, and then again we have to use another oxidizing agent to convert it into alcohol. Right? If you are using mild oxidizing agent too, you have to use. If it is a strong oxidizing agents like this one, alkaline cold KM104 or a potassium dichromate, the alcohol directly gets converted into an acid. Right, then second one. So you have to remember that hot concentrated H2SO4 is serves as a dehydrating agent. Dehydrating, dehydrating agent in the sense it removes the water molecule. That is minus H2O will take place. Wherever the H2SO4 is employed, hot concentrated H2SO4 employs minus H2O takes place. Right, that is the second reaction. Okay, next. With the hard water, a compound functions well. The production of shampoos and other cleaning products uses it. A causes water pollution and it isn't entirely biodegradable. Hard water makes B less effective. There is no water pollution because it is 100% biodegradable. This word itself we can say biodegradable. That means soap. Non-biodegradable. Isn't it entirely biodegradable? That is non-biodegradable. So it indicates detergent. First point. And the compound A functions with hard water. Which functions with hard water easily? The detergent can only function with hard water. Detergent can only function with hard water. So A is a detergent and B is a soap. Right. Next one. A cyclic compound X has a molecular formula. They didn't give anything. It is unsaturated and burns with a sooty flame. Right. Identify X and write its structural formula. It will decolorize bromine water or not. Why? Cyclic compound X with molecular formula. It burns with an unsaturated compound.
Unsaturated
Unsaturated means there should be a double bond. Na?
அப்போ ஏதாவது ஒரு டபுள் பாண்ட் எடுத்து போட்டா கூட கரெக்டாக தானே ஆகும் இப்போ
Cyclic compound. Cyclic compounds mean end to end should be joined. End to end should be joined.
எட்டு சைக்கிளிக் காம்பவுண்ட்னா ஒரே ஒரு காம்பவுண்ட் தான் இருக்கா
No. Several cyclic compounds are there. Let me draw like this. Listen.
எது வேணா எடுத்து ஆன்சரா போடலாம்
Yes. They didn't mention the number of elements, number of carbon, hydrogen. If it is even that is restricted, or else you have to take the smallest possible cyclic compound. Right, the smallest possible cyclic compound. Here we can take, for instance, I am taking benzene. Benzene is a cyclic compound. They didn't mention aromatic compound. Aromatic means we can have the benzene. But they mentioned the cyclic compound with the double bond. So that I made cyclohexane. Remember, if there is a ring in between, that is called benzene. So this is benzene. But this is not benzene. This is cyclohexane. And there is a double bond here, so that it is called a cyclohexene. Cyclohexene, right? Yes. Structural formula we had done. Will it decolorize bromine water or not? Why? Yes, it will decolorize because it's not an aromatic compound. It will decolorize. Let us check the answer. Aromatic compounds I'll explain you later. You just remember that benzene is an aromatic compound. It has a round inside. If the round is not inside, that is called a cyclohexane. The round indicates the three bonds in the benzene. That is, these are the three bonds in the benzene. This round indicates the three bonds. The circular, inner circle indicates the three bonds in the benzene. Right. Anyhow, let us have a look over the answer here.
நீங்க போட்ட பென்சின் தான் இது.
Benzene, they had drawn benzene, but it is not benzene actually. Benzene means there should be three double bonds. This is not benzene actually. Benzene means there should be a double bond here too. Then only it is called benzene. Right. Here, what they are saying is right. What is that? They are saying, what is the question actually? It's a what is the question actually? A cyclic compound acts as a molecular formula. Here, there's a what is that? A gap, a lack of clarity in this question. Actually, cyclic compound is different from aromatic compound. Cyclic compound, aromatic compound, aromatic compound. Let me explain here clearly. Right. Listen here. This is a cyclic compound. This is an aromatic compound. Right? So here, the cyclic compound does not have the properties similar to that of the aromatic compound. This is both are not equal. So if they have to mention the benzene ring, means they might have clearly mentioned as aromatic compound. They might have clearly mentioned the aromatic compound. Because cyclic compounds, we can have several compounds like this. Not only benzene, even we can have cyclopropane, or we can have cyclobutane, or we can have cyclopentane. All these are also cyclic compounds. If you have a double bond, we can say that that is a cyclic compound with a double bond. These are all possible. Then, what is the additional information they had given? They burns with a sooty flame. All unsaturated compounds burns with a sooty flame. Structural formula. Well, will it decolorize bromine water or not? All unsaturated compounds will decolorize bromine water. So I suggest, so this is the right answer for this question. That is, this is the right answer. Either any one of this is right. Cyclopropane is also right. Cyclobutane is also right. They had taken the benzene, but if it is the benzene, they might have mentioned, they must have mentioned the aromatic compound. Or else, what I had done, that answer is right. Yeah, this is right. This is the right form. Either instead of this, you can take even cyclopropane too. This is cyclopropane. If you draw like this is cyclobutene. If you draw like this is cyclopentene. Everything is right. But because of the reason they didn't mention it is aromatic, I strongly oppose this question. This is not the right answer, but that is the right answer. Right? And it does not decolorize. Yeah, in fact, bromine water does not decolorize, but cyclic compounds will decolorize. Right?
இது does not decolorize bromine water. Unsaturated compound தான் இது.
Yeah, the benzene is a special case. We will read it separately. Benzene is an unsaturated compound, but it will not have the property of unsaturation. Right? So benzene will not decolorize. I'll explain you later. This will not decolorize. And next question. Hmm. An organic compound A is a constituent. Let me clear the board first. It is looking clumsy. Yes. Let me read the question meanwhile. An organic compound A is a constituent of antifreeze and has a molecular formula C2H6O. Good. They had given the molecular formula that is comfortable for us to go. Right. Upon reaction with KMnO4, the compound A is oxidized to compound B. Write the chemical equation and identify the compound. Right. So let us check. Let us write the formula first. It is C2H6O,
உனக்கு ketone alkaline
which is alkaline, which is oxidized to UA, oxidized to B, A and B. That's it. So C2H6O. So C2, I had written two carbon atoms. So three hydrogen atoms and one oxygen. So it may be
ketone
CH3, CH2,
double bond
OH. Let me write it clearly. CH3, CH2, OH. So count the number of oxygen and hydrogen here and check it out whether it is right or wrong. C2H6O, is it right? Yes. So this is a compound. So what happens when an alcohol is oxidized with a strong oxidizing agent, Mark?
it becomes acid.
Yeah, very good. Exactly. That is what happened. So it becomes CH3COOH. That's it. That may be the answer here. Let us check the answer. Yes.
கீட்டோன்லேருந்து நம்ம CH3COH கூட மாத்திர மாதிரி எழுதுனால கீட்டோன்
That is also right. What you are saying is also right. Because that too comes with the same formula, na? CH3, C double bond O, CH3. Now, here three carbon atoms are there, na? No, it is ruled out.
No, mister.
Yes.
CH2
No, three carbon atoms are there. They give only two carbon atoms. Na? If it is three means what you are saying is right. So this is the only way to go here. Let's check the answer. Yeah, the same thing. CH3CH2OH. Again, I'm saying K2Cr2O7. Why they had given different formulations for potassium dichromate? I don't know. Right, let it be. So alkaline KMnO4 plus heat. So what is the nature of these two? Strong oxidizing agent. Don't forget, strong oxidizing agent. Oxidizing agent. Right? That's why this alcohol has directly gone to acid. Or else what will happen? If you use weak oxidizing agents,
இது வந்து aldehyde மாதிரி
yeah, aldehyde or ketone, carbonyl compound, it will form a carbonyl compound. Right. Let's go for case study questions. Compounds containing oxygen are of great interest in the field of chemistry because of oxygen's high reactivity is most often found in compounds. Oxygen reacts rapidly with group 1 elements. Okay, let us directly get into the question. I don't have patience to read all these things. If you need answer, we can come again, we can read it. Which metals do not react with oxygen even at higher temperature? What happens when copper metal is heated in air? Almost all metals combine with oxygen to form metal oxides. Is this statement true? This is true only. Almost all metals combine with oxygen. This is true only. Almost. Which metals oxide are soluble in water? Okay. So which metals do not react with oxygen even at higher temperature?
gold
Metals which are highly inert, like that of gold and silver, they do not react highly even at higher temperatures. And what happens when copper metal is heated in air? No, copper forms copper oxide. So black colored copper oxide will be formed as a coat, right? So this is the formula for that one. That is copper plus oxide gives copper oxide. So this is what happens when copper is burnt. And almost all metal oxides form metal oxides. This statement is true. Yes, I said true. It combines oxygen to form metal oxides. Some metal oxides like sodium oxide and potassium oxide, they dissolve in water to form alkalis, right? To dissolve and form alkalis. And some metal oxides like zinc oxide, aluminum oxide show both acidic and basic nature. Those are known as amphoteric. These are the additional points you should have in your mind, right? Then, which metal oxides are soluble in water? Here, there is answer itself. Yeah, sodium oxide and potassium oxides are soluble in water. That's it. That's the end of one question paper for chemistry. This is from biology, and this is from physics.
கொஞ்சம் மேலே இல்லை பயாலஜி டெஸ்ட் டயக்ராம்